Let's take a look at this example. Now please notice that this time we have already points A, B. So I have another pair of points. I'm going to call them X and Y. Now this is going to be my I total. Okay, I total or I source. I total will go through the circuit, okay, through the diode I1 is going to split into two currents, and I'm going to call this current I1 and this current I'm going to call I2. These two currents are going to create again I total over here, and the current I total is going to split again into two currents, and I'm going to call this current I3, and this is going to be my current I4. Okay, so what we're supposed to do? Simply solve this problem. Okay, we have to write the formula first for I total. Okay, so if I total is equal I1 plus I2. Okay, this current plus this current will give me I total. Also, okay, keep in mind, as I said before, this is going to be my I total again. So I total is going to split into current I3 and I4. So I total is also equal I3 plus I4. Okay, and we can also write that I total is going to be equal voltage source, this voltage, minus voltage drop across the diode D1 minus voltage VXY minus voltage VAB. Okay, so let me write this down. Minus VD1 minus VXY minus VAB, everything over R5. Okay, so this voltage minus this voltage minus this voltage divided by this resistance, okay, will give me I total also. So we're going to use these formulas, but in order to find either I total, we're supposed to basically find the currents I1 and I2. We're supposed to find also I3 and I4. So let me write down the formula for I1. I1 is equal VXY minus VD2 over R1. Okay, so this is my formula for current I1. So let's plug in the numbers and check what we can calculate. So I have VXY, I don't know the value yet, minus VD2, which is 0.7 volts, because this is the silicon diode, over R1 1 kilo ohm. Okay, other words, I'm going to write this is VXY times 1 over 1 kilo ohm minus 0.7 volts over 1 kilo ohm. So this is equal VXY times 1 millisiemens minus 0.7 volts over 1 kilo ohm is equal 700 microamps. So I have minus 700 microamps. Okay, so this is my I1. Next I'm supposed to find I2. I2 is equal VXY minus VD3 over R2. So VXY minus voltage drop across the diode D3 divided by R2. So this is VXY minus VD3, which is also silicon, minus 0.7 volts over R2, which is equal to 2 kilo ohms. So this is equal Vxy times 1 divided by 2 kilo ohms minus 0.7 volts divided by 2 kilo ohms. Okay, so this is equal Vxy times 500 microsiemens minus 0.7 volts, 0.7 divided by 2 exponent 3 is equal 350 microamps. So this is 350 microamps. Okay, so this is my I2. Next, I'm supposed to find I3. Okay, so I have I3 is equal, okay, so this is the current which will go through this branch. So this is VAB because I have 2 points over here. So this is my point A and this is B. So this is voltage VAB, I'm going to call it. So VAB minus the voltage drop across the diode D4, so minus VD4 over R3. VAB minus, because this is germanium diode, I'm going to write this is 0.3 volts over R3, which is equal 1 kilo. So this is equal VAB times 1 divided by 1 kilo minus 0.3 volts over 1 kilo. So this is equal VAB times 1 millisiemens minus 300 microamps. Okay, so this is my current I3. Next, I'm supposed to find current I4. I4 is equal VAB minus VD5 divided by R4. VD5 over R4. This is equal VAB minus diode 5 is the silicon diode, so minus 0.3 volts over R4, which is equal 3.3 kilo ohms. So this is equal VAB 1 divided by 3.3 kilo ohms minus 0.3 volts over 3.3 kilo ohms. This is equal I4 VAB, and I have 1 divided by 3.3 kilo ohms, so I have 1 divided by 3.3 exponent 3 equals 303.03 microsiemens, 303.03 microsiemens minus 0.3 divided by 3.3 exponent 3. This is equal 90.9 microamps. 90.9 microamps. Okay, so this is my current I4. Next, I'm supposed to find current I total. Okay, so I have I total. I total, okay, as we said before, is equal voltage source minus VD1 minus VXY minus VAB over R5. So let me copy down this formula. So I have voltage source minus VD1 minus VXY minus VAB over R5. Okay, so what I have, voltage source is equal 50 volts minus VD1, which is equal silicon diode, this is 0.7 volts, minus VXY minus VAB over R5. So this is equal 50 minus 0.7 is equal 49.3. So let me write this down. I total is equal 49.3 volts minus VXY minus VAB over R5, which is equal 4 kilohms. Okay, so this is equal 49.3 volts. Okay, so I have 49.3 volts divided by 4 exponent 3, 12.32 milliamps. So this is 12.32 milliamps minus, okay, so this is like 1 divided by 4 kilo ohms. Okay, so we have 1 divided by 4 exponent 3 is equal to 250 micro Siemens. Okay, so we have 250 micro Siemens VXY minus also 250 micro Siemens VAB. Okay, what I did over here, I simply convert this single fraction into 3 fractions and perform the calculations. I divide 49.3 volts by 4 kilo ohms, I get this. Remember, anytime there is no coefficient next to variable, there's always invisible one. So I divide that invisible one by 4k, that's why I got 250 microsiemens. And also there is invisible coefficient over here. I divided this invisible coefficient by 4k and I get another negative 250 microsiemens. Okay, so let's continue. Now we're supposed to copy these two formulas and solve the system of two linear equations. Okay, so I total is equal I1 plus I2, and I have I total is equal I3 plus I4, where we found that I total is equal these expressions. Okay, instead of I1 I'm going to write this. Instead of I2 I'm going to write this, and instead of I3 I'm going to write this, and instead of I4 I'm going to write this. Okay, so let me get back to the equations. So I have I total, we said, is equal 12.32 milliamps minus 250 microsiemens VXY minus 250 microsiemens VAB. Okay, this is my I total, is equal I1, and as I said before, I1 is VXY 1 millisiemens minus 700 microamps. Okay, so I have V x y times 1 millisiemens minus 700 microamps, and I have plus I2, and we said I2 is Vxy 500 microsiemens minus 350 microamps. Okay, so I have plus I2, which is let me write this down over here, Vxy times 500 microsiemens minus 350 microamps. Okay, so this is my first linear equation. Next, I supposed to plug in the numbers into the second equation. So I have I total, again I'm supposed to copy this down. So I have 12.32 milliamps minus 250 microsiemens Vxy minus 250 microsiemens VAB is equal I3. Okay, so I3 is VAB times 1 millisiemens minus 300 microamps. So I have VAB times 1 millisiemens minus 300 microamps plus I4. I4 we said is equal VAB times 303.03 microsiemens minus 90.9 microamps. Okay, so I have VAB and I have 303.03 microsiemens minus 90.9 microamps. Okay, so I have my two equations. Next, I'm supposed to organize them a little bit. Okay, so I'm going to bring all Vx and VAB values to the left side, and everything without V I'm going to move to the right side. So I'm going to have in the first equation minus 250 microsiemens Vxy. Okay, I'm going to copy this down. On the right side I have Vx 1 millisiemens, so I'm going to move this to the left side, so I have negative. Let me copy this down like it is over here. So Vxy 1 millisiemens, and I have also Vx over here, so I'm going to move this to the left side also, so I'm going to change the sign, so I have negative Vxy times 500 microsiemens. Okay, next I supposed to have AB. Okay, so I have negative 250 microsiemens VAB. Everything is equal, and I have this. Okay, so this is negative 12.32 milliamps, and I have negative because I have to move this to the right side. Okay, and I copy down negative 700 microamps, and I have negative 350 microamps. Okay, so this is my first equation. Let's do second one. So what we have negative 250 microsiemens, and I have Vxy, and I have negative 250 microsiemens VAB. I'm going to move this VAB to the left side, so I'm going to have negative VAB times 1 millisiemens, and I have negative VAB 303.03 microsiemens. Okay, this is equal, and I'm going to move 12.32 milliamps to the right side, so I'm going to have negative 12.32 milliamps, and I have on the right side negative 90.9 microamps. Okay, so I got my two linear equations. Next, I'm supposed to simply combine the like terms. So I have negative 250 exponent 6 negative, and I have minus 1 exponent 3 negative, and I have minus 500 exponent 6 negative. This is equal negative 1.7 millisiemens VXY. Okay, so this is negative 1.75 millisiemens VXY. And I have over here negative 250 microsiemens, so I have minus 250 microsiemens VAB. This is equal, and I have 12.32 negative exponent 3 negative minus 700 exponent 6 negative minus 350 exponent 6 negative. Okay, this is equal negative 13.37 milliamps. Negative 13.37 milliamps. Next, we're supposed to look at the second equation. Okay, so we have negative 250 microsiemens VXY. So let's copy down this value. So I have 250 microsiemens VXY, and I have my VABs. So as you can see, that we have minus, I suppose to say negative 250 exponent 6 negative minus 1 exponent 3 negative minus 303.03 exponent, this one, 6 negative. Okay, this is equal 1.55, okay, millisiemens. So I have negative 1.55 millisiemens, and this is equal, we have to add the currents. We have negative 12.32 exponent 3 negative minus 90.09 exponent 6 negative. Okay, so I have negative 12.41 milliamps. Negative 12.41 milliamps. I said add because we have two negative numbers, so we have to add them up and keep the sign. So we obtain two linear equations. Okay, so next we are going to use the calculator to find values of VXY and values VAB. This is of course VAB. So I have negative 1.75 exponent 3 negative. Okay, next one I have negative 250 exponent 6 negative, and I have negative 13.37 exponent 3 negative. And I have 250 negative exponent 6 negative, and I have negative 1.55 exponent 3 negative, and I have negative 12.41 exponent 3 negative. Okay, so my Vxy is equal 6.64 volts. VAB is equal 6.93 volts. Okay, so I found the voltages Vxy and VAB. Next, we're supposed to find the value of current IR1. Please notice that the current IR1 is equal to I1 because I1 will go through resistor R1. So if you are going to look at my notes, you are going to see that I found already formula for I1. So I'm going to use this formula and the value of Vxy, which I just found, and I'm going to find the current I1. So let me copy this down. So I have I1 is equal IR1, and this is equal Vxy minus VD2 over R1, where Vxy we found is equal 6.64 volts minus VD2. VD2 is 0.7 volts because this is silicon diode. Okay, so I have minus 0.7 volts over R1. R1 is equal 1 kilo. Okay, so let me use the calculator. So I have 6.64 minus 0.7 is equal, divided by 1 exponent 3 is equal 5.94 milliamps. And this is my current IR1, the current which will go through resistor R1. Next, I'm supposed to find IR2. IR2 is the current which will go through resistor R2, and please realize that I2 will go also through the resistor R2. So if I'm going to find I2, this is going to be equivalent to IR2. The formula for I2 we obtain over here. Okay, so let me copy down this formula. So I have I2 is equal to IR2, and this is equal Vxy minus VD3 over R2, where Vxy we found is equal 6.64 volts minus 0.7 volts over R2, which is equal to 2 kilo ohms. Okay, so we have 6.64 minus 0.7 equals, divided by 2 exponent 3 equals 2.97 milliamps. Okay, so this is the current which will go through resistor R2. Next, we're supposed to find the power at resistor R4. Okay, so power at this resistor. So in order to find the power at this resistor, we're supposed to find the current which goes through this resistor or voltage across this resistor. Okay, so I'm going to find this time voltage across this resistor. Please notice that we have the value already of the voltage VAB. So if we are going to subtract from VAB voltage of the silicon diode, we are going to obtain the voltage across resistor R4. So we can say that VR4 is equal VAB minus VD5. Okay, so VAB is equal 6.93 volts minus 0.7 volts. Okay, this is equal 6.23 volts. Okay, so this is the voltage across resistor R4. Next, we are going to use the formula for power, which says PR4 is equal VR4 to the second power over resistor R4. This is equal, so VR4 is equal 6.23 volts, I have 6.23 volts, and this has to be raised to the second power, divided by resistor R4, which is equal 3.3 kilo ohms, and this is equal, I'm going to use the calculator, I have 6.23 to the second power divided by 3.3 exponent 3. This is equal 11.76 milliwatts. So I have 11.76 milliwatts. Okay, so this is my power PR4. Next, I'm supposed to find the power at the diode D5. Okay, power at this diode. So I know that the current which goes through the diode is equal to I4, and I know that the voltage drop across this diode is 0.7 volts. So I'm going to use the formula P D5, okay, is equal I4 times V D5. So we can say that I4 is equal VR4 over R4 times VD5, which is equal 0.7 volts. So this is equal VR4 we found is equal 6.23 volts over R4, which is equal 3.3 kilo ohms times 0.7 volts. So this is equal 6.23 divided by 3.3 exponent 3. Okay, and this is my current I4 times 0.7 volts. This is equal 1.32 milliwatts. Okay, so this is the power at the diode D5. Next, the problem is asking me for voltage VAB, but please notice that we found voltage VAB. VAB is equal 6.93 volts. So now we can say that the problem is solved.